I'm Mark Bickhard. I got into this a long time ago, centuries ago, not just decades ago. Uh, I was interested in things that just did not fit with the standard conceptions of what psychology is. And so I've done a fair amount of work trying to figure out how science should work and how psychology should work,
Right.
um, that at least makes some sense out of what I'm trying to do. Today, I'm going to mostly be able to just indicate some problems that I see in psychology and some of the history of how we got there. So let's see if this works. Now,
Yep.
can you see the screen?
Yes, we can see the screen and we can hear you very well. So
Okay.
the floor is yours.
Okay, so most of this is going to be critical in a sense. That incidentally is the abstract. Uh, I'm just going to wave my hands a little bit at a more positive model of how science and psychology should work. I want to go back to Ernst Mach, his work in the later part of the 19th century. Of relevance to what I want to talk about, Mach was a very, very strong empiricist. He thought that science was a matter of collecting data patterns, that theoretical terms were basically just abbreviations for data patterns. And he was a very, very smart guy and seemed to be able to resolve lots and lots of problems with classical empiricism. He had a very, very strong influence on the early logical positivists, the early logical empiricists, analytic philosophy, and so on and so on. And one of the influences he had was the development of verificationism, which was the idea that the meaning of a statement was the means by which it could be verified. And operationalism, the idea that the meaning of a term is the data pattern that it summarizes or that defines it. All of these failed. Verificationism fails. You can't, well, an example, all swans are white. You can't examine all swans. So there's no way to verify it. All copper is conductive. You can't examine all samples of copper. So you can't verify it. There was an attempt to shift to falsificationism, that the meaning of a sentence was the means by which you could potentially falsify it. That didn't work either. And then we have operationalism, which actually got proposed by Bridgman in the 30s. That failed, and the logical positivists and logical empiricists realized that it failed. Psychology has not realized that it failed, almost a century later. But you cannot, just for an example, you cannot operationally define dispositional terms like soluble. An intuitive attempt might be to say, well, something is soluble if when you put it in water, it dissolves. Sounds nice, but what if you never put it in water? So if you never put your cube of iron in water, then it is either soluble or might be soluble. You just don't know. There was a whole lot of work done to try to figure this out, and nobody ever succeeded. And this was one realm of reasons why operationalism was decided to fail. Hempel has work in the 1930s that talks about this. Unfortunately, most scientific terms are dispositional. They are about what could or would happen, not about what did happen. And so this was a particularly strong failure on the part of operationalism. Bridgman's attempt to do this was an attempt to construct a theory of definition in terms of strict observables. It was straight empiricism. It failed, as I said, and the logical positivists realized that it failed, but psychology held on to observables in behaviorism and in operationalism, and it has not fully escaped. Psychology has gotten away from the little hyphens, the associations in behaviorism, but it has not gotten away from operationalism. Well, what do you do with unobservables? Unobservables seem to be really problematic if you happen to be trying to deal with them scientifically. Physics had to deal with this in the 19th century with Faraday and so on. Electric and magnetic fields are not observable. So how can you do anything with them? How do you study them? Well, they realized and discovered that you can develop theories about them. And from those theories, you can derive consequences that are in fact observable so that you can do tests of the theories. And the logical positivists and logical empiricists realized this. And again, for about the dozenth time, psychology has not. So psychology had to give up the behavioristic restriction to observables only maybe 1960, plus or minus a bunch of years, with the advent of computationalism. You cannot observe a computer program that's running in the computer. But that doesn't mean you can't test consequences or hypothesize consequences of the program. So you can still study them. So in a certain sense, psychology gave up the strict restriction to observables a long time ago, but multiple vestiges still distort this move. You pick up any introductory psychology textbook and it'll talk about operational definitions. A parenthetical, computationalism is also untenable as a model of psychological processes. So although it forced psychology to do one half step in the right direction, my argument at least is that it ultimately doesn't work itself. So the ideology of operationalism still dominates psychology. It maintains a commitment to empiricism in the development and testing of theories. It gives you the idea that the meanings of theoretical terms are strictly empirical, are operationally defined and definable. This doesn't work, but it has been maintained, at least in part, I think, because we now use in psychology the word operational definition so loosely that we tend to use it to mean something that is legitimate, and that is just being careful about how you're going to measure something, about how you're going to categorize things, about how you're going to do whatever you do, your observations, your interventions, whatever it might be. And so being careful about your methodology, your procedures in that sense makes perfectly good sense, but those are not operational definitions. They don't define terms. They don't define theoretical terms. And the descent and still dominance of operationalism as an ideology in psychology prevents people from understanding how theory really works. It prevents people from understanding how theoretical terms might actually have some meaning. So we have a requirement for some sort of a non-empiricist approach to meaning. It also supports inductivism. You just collect lots and lots of evidence that somehow is in favor of something. Sort of dust mote empiricism, if you will. And this just doesn't work. Nobody's ever been able to make sense out of these inductivist intuitions. We test, we don't collect inductive support. The idea of inductivism distorts methodology and design. So for example, on a pure inductivist model, you cannot justify something like a control group. What does a control group have to do with building up a huge pile of inductive support for something? Inductivism distorts the teaching and understanding of statistics because statistics does not do inductive work. And I wrote a paper about this a long time ago, and I've shown it to multiple major statisticians who have written, some of the major textbooks in statistics, and they all said, oh, I wish I could write a book like that, but nobody would buy it and nobody would read it because the empiricist, operationalist, inductivist ideology is so strong. Okay, so if we're going to do testing rather than inductive support, this requires the kind of data that is the result of deriving consequences from some theory or hypothesis or some understanding or wherever it comes from. These can be qualitative or quantitative. the split seems to me to be itself a kind of a manifestation of the underlying empiricism. There really isn't, in terms of testing, any necessary difference between qualitative or quantitative. So even in physics, electron spin up or electron spin down is not quantitative, it's qualitative. It's a pure dichotomy. It's either one or it's the other. Physics envy gets the physics wrong because it assumes the physics always involves measurement into real numbers or something like that. Which brings me to an issue that's extremely important, but I'll only have a moment to say something about it, and that is, what is measurement? Measurement is, quote, just, unquote, description. So if you have open-ended descriptive categories, that's one kind of description. Suppose you have a list of nominal categories, that's another kind of description. Suppose you have a list of categories that happen to be ordered. Well, some people would start calling that measurement by now. What if you have a list of categories that happens to fit an interval scale or even a ratio scale? Then almost everybody would call it measurement. But notice, it's all just description. That what makes the difference is the structure of the potential descriptions you might come up with. And that goes a long way because, again, it crosses the divide between qualitative and quantitative. Well, if induction support is not the only thing, and as a matter of fact is an impossible thing for science to do, what is science doing? And here I'm just going to wave my hands at a few things. This is not an exhaustive list. It's just an illustration that there are more than one kinds of things that science can do and that psychology can do, more than one kind of questions, more than one kind of hypotheses. Of course, we all know about experimental. Some of us know about quasi-experimental. Those have their uses for certain purposes. We can be looking for population distributions, causal hypotheses, existence research. This is very underappreciated in psychology. Does some phenomenon exist? Can we discover brand new phenomena? Participant observation and related methodologies can be quite important for this kind of research. We can test alternatives against one another. That's a very powerful one that you sometimes see in psychology, but rarely. We can be looking for explanation or we can be looking for engagement and involvement. We can try to figure out ontologies of the phenomena that we're looking at. And as I say, this is not an exhaustive list. It's just an illustration that psychology is in a really bad Procrustean bed about the way it thinks about methodology. And then finally, persons. Psychology intrinsically involves normativity, which physics does not. So psychology is worried about things like functional, dysfunctional, true, false, rational, irrational, meaningful, not meaningful, and so on. These are all normative phenomena. Persons are intrinsically normative. Persons, as a kind of epitome of the point, are not operationally definable. You cannot empirically define a person. That doesn't mean that you can't study hypotheses, ideas, understandings, and so on about persons, but you can't operationally define them. So empiricism is particularly destructive for anything that is normative, because a dominant assumption that everybody has in the background of their thinking, even in psychology, is the assumption that norms and facts do not metaphysically relate. This, of course, derives from Hume, know aught from is. And that sets aside the normative realm as particularly problematic for study. And it makes all of the problems in physics resident in psychology, but it makes psychology have its own realm of problems having to do with these normativities. So the underlying empiricism, the underlying operational definitions, yields distortions, yields denials, yields ignorings of what psychology is ultimately about. It basically yields ignoring the fundamental subject matter namely persons of psychology. And that is Idaho Hack.